It is significant that the planets have an electrical charge of the same type used for what are called charged coupled devices and other technologies that have to do with charged particle optical technology, with the charged particles from the sun playing their roles in a way that is consistent with the dynamics of charged coupled device digital imaging chips, as well as optical diodes and sensors and other technologies that utilize light. This includes cameras that are now using what are called CCD and CMOS and other chips that have replaced film in modern camera equipment, including microscopes and telescopes and spectroscopes and so forth. And I will repeat myself in this video when I say that the internal and external structure and dynamics and even coloring of the planets in some cases are respective mirror images of the internal and external structure and dynamics of these optical technologies we are comparing the planets to, as well as moons that I think are all technology disguised as Mother Nature. In particular, I think the charged planets and moons are the equivalent of charged coupled devices, which include CMOS and DSLR chips, the acronyms of which I won't elaborate on any further. These chips are devices that convert photons to electrons, analog signals to digital signals. I think all the planets and moons in our universe are playing their role as charged, coupled digital imaging devices / sensors / cameras that record everything going on around them. And I think this could include black holes, which are supposedly charged like charged coupled devices in a concept that I will elaborate on later in this video, with the gas giant outer planets of Saturn, Jupiter, Uranus, and Neptune playing their especially colorful roles as digital imaging chips in cameras and sensors and so forth. And this includes their ring structures, all of which are mirror images of these digital imaging camera chips, not just in color, but structurally and electromagnetically, as well as chemically. And as we move along with the shortest attention spans in the history of the world, let us note once again how the gas giant and the rest of the planets, perhaps, could also be compared to these optical diodes / light sensors, which are devices that turn light into electrical current. This is the result of light from an emitter bouncing off an object and being reflected into an optical / light detector diode / sensor of some kind, with this principle applying to the previously examined digital camera chips like the CCD chips and so forth, with the light from the sun bouncing off virtually all of the planets and moons in our solar system, as if bouncing off optical diodes and imaging chips and sensors and so forth, all of which are used for a wide range of optical and camera technology products that have been developed within the last few decades, including biotechnology and communications and other devices that we will examine later on in this video, with the planets and moons in our and other solar systems probably picking up optical signals from life forms that happen to evolve on these planets and moons, with solar systems at large being some kind of omnidirectional electromagnetic sensor slash imaging slash camera and communication devices that are so sophisticated that we don't even recognize them as technology. The same could be said of the galaxies and the rest of the universe at large. The universe is pure technology disguised as Mother Nature. And we can see how the external and internal structure and dynamics of these diodes and charged coupled devices and so forth, as previously noted, are pretty much the same as the planets and so forth. With me going off on a tangent here, this brings us back to what are called charged black holes, which appear to in part be serving as some kind of charged coupled device, digital imaging chips slash cameras slash photodiodes slash sensors and other technologies. And this would include diodes that perhaps play dual roles as receiver and emitter diodes here, including infrared receiver diodes, plus diodes that play dual roles as receiver and emitter diodes, which emit and receive signals simultaneously, just like how black holes are receiving and emitting all kinds of radiation simultaneously, including infrared and other types of radiation. This dynamic is the same dynamic as the emitter-receiver systems in any number of optical biosensing and computing and other technologies that have been on the market for the last few decades, all of which are manufactured with lots of silicone, and silicone is abundant in the planets and moons and probably black holes and the suns as well. And this brings us to the fact that the suns appear to be playing their obvious roles as the ultimate emitter of light and other forms of soft and hard radiation that is used in biological imaging equipment, as well as any number of other consumer and industrial products that use optical diodes and laser diodes and cathodes and so forth. The same could be said of any number of trillions of suns in the universe, all of which are partially made of silicone, like some of these light-emitting diodes. This means that the suns, like our own, appear to serve as light-emitting diodes and or lasers that are working in tandem with optical receiver diodes in a spectrographic relationship that brings these optical sensors into relevance that you are looking at now as just another set of consumer and medical and industrial products. This includes a line of related products called surface plasmon resonance biosensors, which are based on a sensing technique called surface enhanced spectrography, plus other techniques we are or will be glancing at briefly as we notice how the interactions among the Earth, the Sun, and Moon are abstract mirror images of these surface plasmon resonance biosensor chips and microsphere biosensor resonators, whereby the Moon would play the role as optical receiver or detector or sensor diode or lens or related role relative to the Sun's role as light-emitting diode and or laser or infrared transmitter or something to that effect. This dynamic, as previously indicated, could apply to any of these devices that I am showing you in no particular order at this point, and many of them are not adequately labeled, if at all. All of these devices use one form of spectrography or another and the more abstract and very simple similarities between the structure and dynamics of our solar system and these simple receiver and transmitter diodes cannot be discounted, especially when we factor in the chemical similarities between these devices and the planets, moons, and even the suns, plus the high probability that their respective chemical proportions are also similar. And as we move into the next section, bear in mind that these microscope and spectroscopes we see here all use some kind of digital imaging and optical sensor chips and diodes, including CCD and CMOS and related chips and diodes, some of which we have already seen and compared to the planets and our moon. These pictures of these particular microscope and spectroscope setups I picked specifically because the types of digital sensor chips and their cameras are clearly labeled for us to see, including with regard to their organization around their target specimens. Not unlike the moon and the outer and inner planets are organized around the Earth and ourselves in a roundabout way, but much farther away. And we must also not forget that the geochemical and atmospheric chemical composition of the planets and moons contain the basic elements that these digital chips are made of, and vice versa, including lots of metals and silicon and their respective oxides, the latter of which is basically sand and quartz, plus other crystals which are abundant in the planets and moons in our solar system, including the Earth. And with Earth being the only example I will use, it seems the Earth is in part a CMOS digital imaging semiconductor chip merged with what is called a microfluidic lab-on-a-chip, which is a chip-sized mini biological sensor for microscopic analysis of cells and DNA. The same elements these chips are made of probably exist in the same proportion in the inner planets like Earth. The Earth is in part, and more specifically, I think, a spherical microfluidic lab-on-a-chip biosensor of some kind, with some kind of built-in camera lens, kind of like these examples. Over 70% of the Earth is also covered with water, which is consistent with my Earth as a microfluidic biosensor theory. The Earth and the rest of the planets and moons are not cotton candy floating in space like meaningless rocks and dirt. And let us focus on the interior dynamics of the Earth compared to ourselves. This is what we would be looking at. The core of the Earth, the layers of the Earth, have all the trappings of the sensor technologies that you see here. We are being analyzed and scanned, I think, from the interior of the Earth. And when we bring in the sun, this changes the equation to what is called optical fluidics or optofluidics or something to that effect. And this includes a lab-on-chip platform. But because the Earth is not flat like a chip, and because the Earth is round, then what we have is some kind of optical magnetic microsphere resonator platform. Some of these devices are called laboratory-on-chip microsphere biosensors and are based on a sensing technique called cavity-based spectrography and sensing. They are a mirror image of the Earth in its relation to the Sun, and that's not even the half of it. But they are just another set of tools used by doctors and scientists to detect and analyze cells, DNA, nanoparticles, and other matter at the microscopic level using the forces of light as analytics, excitation, and manipulation agents. Some of these microsphere biosensors are specifically referred to as optical and or dielectric and or magnetic microsphere spectroscopes, and the dynamics of these devices are near mirror images of the electromagnetic relationships between the Earth, the Moon, and the Sun. And the electromagnetic relationship among the Earth, the Moon, and the Sun, especially with regard to the twin forces of light and magnetism, respectively, are more or less identical to the relationship of laser emitters and optical sensors relative to the target specimens inside these optical and or magnetic biosensor resonator spectroscopes. And some of these microsphere biosensors are also constructed in layers, just like the Earth is layered, as well as made of the same elements as these microsphere biosensors that you see. These microsphere biosensors rely on a biological sensing technique called optical and or magnetic resonance and light scattering, which are dynamics that play out in Earth's atmosphere and elsewhere in relation to the Sun, with light scattering dynamics between the Sun and the Earth being the same exact language used to describe the light scattering biosensing spectrography technique called Raman and fluorescence scattering, including Rayleigh and fluorescence scattering, plus other types of spectrography. These microsphere biosensors use optical fibers as what are called waveguides, whereas Earth's Schumann resonance field also acts as a waveguide and the equivalent of a resonance cavity, not unlike these examples here with the optical waveguide for this dielectric optical microsphere biosensor. What we have here is a scenario in which the dynamics and language of microsphere biosensor physics and the physics of earth science are bleeding into each other. This includes words like magnetic and optical resonance and Raman and Rayleigh scattering, fluorescence interactions and absorption, waveguides, resonance cavities, bandwidth, dielectric spheres, electromagnetic fields, and so forth. The fusion of the dynamics and language of biosensor physics and earth physics extends to radio physics as well, because it seems that the Earth and the other living planets and moons are spherical dielectric antennas of some kind. The Earth and the other living planets are also layered like these spherical antennas, and their relationship to the Sun render them some kind of dielectric lens antennas merged with dielectric microspheres, perhaps, like the Earth, the dynamics of which I will not elaborate on any further. But Earth is a fusion of many technologies, and this assertion is supported by the fact that the geochemical composition of the Earth is comprised of the same elements as the technology you see in this video, in addition to being structured like the technologies we see here. But it seems we have three choices of what to believe as far as the universe. we have the magical universe, which is the theological universe. Then we have the nihilistic universe, which is the universe that scientists and atheists like to cling to. And then we have the cybernetic universe, which is my vision of the universe. And I don't think it is less realistic than the magic vision of the universe, or the nihilistic vision of the universe. I am going to wrap up this video by saying that I believe that solar systems are some kind of equal opportunity observation platform, microscope platform, or something to that effect, whereby the planets in any particular solar system that evolve life automatically become targets of this platform. I think the solar systems could be any number of technologies, including imaging technology, communications technology, computer technology, and so forth and so on. And if you like this video, subscribe, hit the like button, share, and I have other videos out there on YouTube, and there is a playlist at the end of this video if you want to see more.